So it's calculated, and the coefficient here is called a Weber coefficient. So it's like a threshold value of the contrast where we see the actual differences between two pixels that are next to each other. Yes, so we can calculate this, and here we have the real example. So it's just like a showcase. So if we have let's say a display, OLED display, this is like one screen, this is the second screen, and normally let's say we have a watch there, yes, like showing the time, and we have the arrows moved around, and we have the circle, and let's say for most of the time we have this image, yes, and sometimes we go to our menu and see something else on our screen. Then after, let's say, maybe some years of usage or months, we may have a situation where the circle brightness will decrease a little bit lower, like you see here. Of course, this image is like specially prepared to show it strongly, and then the arrows will have a little bit higher brightness, but still a little bit lower than the normal, yes, the background, which is not used that often. And this is something that we may see on OLED displays after some time. So the use case here would be to switching the colors. So that means we can like switch the background, let's say, to be like in a negative way. Yes, so let's say for 1 hour we have a watch like this, and for another hour we make the background on, and then we switch off the watch itself. Yes, so we try to keep the pixels in an on state all the time. It's not maybe very important. In most of the cases you don't need to be worried about that. But if you have something like, as I said, 24 hours information in some place of your display, you may want maybe to move it. Let's say, yeah, switching off. Okay, so you can also move this watch, yes, from time to time. Yeah, we can use entire display all the time, of course. And another way is to implementing a controller that use a grayscale. This is more complicated. I have done this once in my lifetime only, working with OLED displays where we needed to calculate the time of the pixels where they were switched on, and it was done in a controller, in a microcontroller that was driving this to use the grayscale that was in the display to change. So I knew that this pixel is long, and I knew the function, how it will decrease the brightness. So we were able to manually increase the brightness in this area to keep the display all the time with the same brightness. But it is very, I would say it's complicated. It required a lot of programming power. So normally it's easier maybe to move your screen around.